Hello students, in this session we are going to study the angle of twist. In the continuation of the closed coil helical spring, we have already found out the shear stress developed in the spring material, maximum shear stress developed. Now we want to find out the angle of twist. What is the angle of twist developed? You know that whenever a shear stress is developing, it means we are applying a torque. There will be an angle of twist, right? Remember the formula. So what will be the angle of twist in the spring wire? So here we want to find out the angle of twist. So our topic is angle of twist in a wire of closed coil helical spring. Wire of closed coil helical spring wire. So what will be the angle of twist? Angle of twist in the closed coil helical spring. We have to go our torsion equation, basic torsion equation. What is that? T by J equal to tau by R equal to G theta upon L. Here it is theta. This theta is basically the angle of twist, and this we have to find out. Angle of twist. So this we have to find out. So use this equation. T by J equal to G theta upon L, these two equations, and find out theta from here. So what will be theta? Theta will be equal to TL upon GJ. TL upon GJ. This is our basic equation. What is T? Torque. In the previous section we have find out two things, right? T, L and J. What is T? Torque, that is WR. Remember the previous session of this class. And L is 2 pi Rn, right? Remember that 2 pi R and N. 2 pi Rn. 2 pi Rn is the length of that spring. 2 pi R is the capital R basically. 2 pi Rn is the length of the spring upon G, modulus of rigidity, and J is the polar moment of inertia, pi by 32 d to the power 4, right? So torque is WR, length of the spring 2 pi Rn, G pi by 30 d to the power 4, d is the diameter of the wire, and R is the mean radius, right? For finding the length you need the mean radius, right? 2 pi Rn, some circumference, length of the circumference multiplied by number of turns, that will give the total length of the spring, right? Because there is no gap, we are neglecting the gap between the spring coils, because this is a closed coil helical spring and there is very negligible gap between the coils. That's why we are not adding these gaps. We are just taking the 2 pi R, the circumference, multiplied by the number of turns, how many turns are there, and that will give the length of the spring, right? So 2 pi Rn, G, and polar moment of inertia is pi by 32 d to the power 4. Solve it and you will get the relation as angle of twist will be equal to 32 will be multiplied by 2, this will become 64 W R square N, W R square N by G d to the power 4. G d to the power 4. So this is the formula for angle of twist. In spring, in closed coil helical springs, you have to remember the formula. Most of the questions are based on formula, right? And concept is very less. And if you want to derive that formula, you can derive, but you have to remember the ready-made formulas for this. So this is very important. The angle of twist for a closed coil helical spring.